3, 2, 1.
Hello and welcome to Innovating for the Earth, in which we tell the story of an Australian company, Calix, whose technology, a reinvention of the kiln for big industrial processes, is helping many industries operate in a more sustainable way and emit less carbon dioxide. The unsung heroes of this world, in my opinion, are engineers. Sure, people talk about Einstein and Marco Polo and Shakespeare and Steve Jobs and Winston Churchill and Nelson Mandela and Rihanna. And yes, good on them, amazing stuff. But the fact is that none of these high achievers would have been able to do much at all without engineers. Every time you drive on a road or a bridge or through a tunnel or get on a bus or a train or enter a tall building or open your laptop or tap on your phone, you're only able to do it because of engineers. Maybe someone else had the idea to build the road or the laptop, although engineers have plenty of ideas. But engineers turn those ideas into things that actually work and that we can use. Without them, we wouldn't be able to go anywhere or do anything. So let's examine how the engineering happens in Calix. Matt Gill is a Calix project engineer, which is a typically anonymous engineering title, right on brand for the behind-the-scenes loving engineering profession. Matt's LinkedIn profile doesn't even have a photo. It wasn't easy to find out about him, but I've discovered he graduated with a degree in mechanical engineering from the University of New South Wales in 2011. In 2012, he joined Calix. His first job was as a mechanical engineer for the Calix Flash calciner. He helped develop the ActiMag product. In 2016, he worked in Europe on the Lilac project, then back to Australia, where he was in charge of developing an electric calciner for processing innovative battery materials. In 2019, Matt became the engineer team leader, and here he is. Matt, hello.
Hello, welcome.
Thank you, and welcome to you. Let's go right back. Why did you decide to study engineering? Why did you want to become an engineer?
It's an interesting question. I guess I didn't really have any direction up until the end of high school. And then I was doing the usual university sort of open days, inspection days, and came across what is known as Formula SAE at the University of New South Wales, which is basically each year they build their own new race car. Myself being involved with motorsport as a kid, this sort of triggered I'm going to do engineering. I want to do this. I want to get involved with designing and building a race car. It fascinates me, and that triggered it. I was always mechanically inclined, but I guess I never really had the direct direction as to where I wanted to go.
Yeah.
And that was a light bulb moment for me.
That's so interesting, isn't it? Because when my dad tried to explain to me how a lawnmower worked, I just blanked out. I didn't even hear it. So it is interesting how some people, some brains are drawn to that and some aren't at all.
Yeah, exactly. It's I think the Dilbert, the comments is precisely based on there's one particular one where it's talking about the sun is pulling something to pieces, and he goes, "Oh, well, you've got an engineer," the doctor says, because of the way he's deconstructing and reconstructing it. I think fundamentally that is ingrained in the majority of engineers out there. They have to know more than what the visual shows you. They want to know how it works.
It's a curiosity.
It's a curiosity, yeah. For better or worse in some cases, but it's definitely.
And so when you graduated, why did you join Calix?
It's an interesting story. There was no direct line I was looking for to join Calix. I'd been travelling Europe post-university, which unfortunately kids can't do nowadays, but I came back and accidentally crashed my car. Simon Thompson, who I believe you've already interviewed, sent out a message to the group of people involved with the race car, saying, they're going to go to LinkedIn and advertise this job. Happened to be on the day I crashed my car, realised I needed some cash to get into the workforce, and I applied. And that started my relationship with Calix. Now, it sounds like that relationship's not built on much, and yes, at the start it wasn't, but once I joined Calix and got involved with what it is, my mentality towards the world and how we have to work towards, ensuring that future generations can live here in a nice environment changed. It basically sparked that in me, that
And so when you joined Calix in 2012, was that ethos of innovating for the earth, the title of this podcast, was that clear to you then, or did it kind of arise gradually over the years?
No, it was definitely there from the start. The leadership team had this vision to develop this technology that will help society as we move forward through this evolution we're going through. And as I mentioned, I didn't have any direction through high school and then university where I wanted to get involved with this, trying to save the world, trying to make it a better place for the next generations. So I was, let's say, the complete opposite to what the management had, but I was exposed to what was happening and what we needed to do, and that changed me.
It connected with you.
That connected with me.
Okay.
That showed me what we needed to do, how bad the situation was, and where we need to go.
So that's big picture, and we've talked about that a fair bit on the podcast. In this episode, we want to get into the nuts and bolts of the engineering. What was your first job? What did you have to do?
Oh, my first job. We were at that
Calix.
stage. We had a concept of the technology. They'd proven it on a small scale, which is relatively easy. You don't have the constraints of trying to make something commercialized. So we were trying to take this idea, this concept, and make it large, make it effective, make it cost effective and efficient, so that we could hit those targets, those dreams. So we were molding it to try and make it large scale.
You mean the calciner?
The technology, the calciner. This.
And what did that actually involve? Like, give us a snapshot of an hour. What sort of a problem or a challenge might you have been grappling with?
To begin with, we were all sitting in a room, bunch of engineers, Simon, myself, and a couple of others, and we had this. Say we had to design a heat exchanger for it, and this is a conceptual heat exchanger, but we needed to bring it to life. So at that stage, we were hand sketching and then taking it through to a CAD design, which is a 3D model, and then doing the calculations. And so in the background, while you have this pretty image on the website of, say, a segregated furnace, calciner, and then reactor, we were at that stage, but developing it in a real world situation. We were making sure that it would work, it would look this way, it's going to function as we are predicting.
It's funny when you were saying that. I've been in a few writers' rooms for TV shows, right? And it made me think of that, because you've got a number of people in a room. They've kind of got an outline for what they want the show to look like, but they're going through and filling in all the details. And then halfway through episode 4, there's a problem, and it looks like the whole show might fall apart because you can't work out how to solve it. And then you all have a terrible day. And then the next morning someone thinks, wait a minute, what if we do that? Is it kind of a little bit like that but totally different?
Precisely, except probably the difference is you go out and have a few beers as a group, and then you come up with all these ideas that are outside of what you perceive as normal limitations, and that's when that click happens. And then we all come back together, discuss it, and
and then I guess the next step is trialing it, and then seeing if it fails or succeeds.
Precisely.
Yeah.
Well,
and then if it fails, not saying, "Oh no, we've failed. This is a disaster." Why did it fail?
Why did it fail, and how are we going to fix it?
Yeah. What bit failed?
Yes, exactly. Finding that weakest link and making it as strong as the rest.
So you're like a detective. In a way.
You could say so, yeah. Basically, you're trying to find where you made the mistake, because it was your design originally, and resolve it. You're trying to make sure it's all as strong as each other.
Yeah, right. And so there must be, great highs and lows there. Oh, we failed again. But wait, it's because of this. Maybe if we use that.
It's definitely an emotional roller coaster. It's a mental hit when you realize you got something wrong. But you have the ability in the background to resolve that and build it again stronger and make it work. So,
can you think of a specific example of that?
Definitely. We have this device that takes up the expansion in our reactor. So as we heat up, the metal obviously expands. So you've got to seal that process environment from the atmosphere environment. Now, this is occurring at incredibly high temperatures and is very difficult to work. So we've gone through 3 or 4 design iterations where we've had complete failures each time. And basically on the 3rd or 4th iteration, we stepped back and said, how can we look at this from a whole new point of perspective? And what we were using is sort of like a fabric expansion bellow. And now we've gone already to a more conventional sort of design where we're using a compression seal, which is taking up that expansion. And it's working fantastically. It's solved that issue.
Right.
But there are a lot of lows during the times where you'd spend all this time, energy and effort to come up with a new design and then it to fail reasonably quickly.
Yeah. And what sustains you through them? Kind of the larger vision or hope?
Yeah, well, you have the ability to solve it. It's just
Right.
making sure you find that solution. So you're treating it as an educational experience where you've learned you've got a bit more data here. So okay, if you're walking down a path, that path's not going to lead you to a solution. It's going to take you to a creek. Whereas the path here will take you to a bridge that'll get you over that creek. And, there's still a mountain you've got to climb later. But you're at least moving down further along that path towards that optimized solution.
I mean, it's like if you're reading a murder mystery. If the detective kind of in chapter 1 thinks, it was definitely that guy, we got him, it's a pretty bad story, isn't it?
Yeah,
so
exactly, precisely.
It's not very satisfying. Whereas all the challenges and whatever make it...
Precisely. And I think that's the function of an engineer. You've got to expect those non-one-hit solutions. It's going to be a growth path that you will have to go through and that you have to educate yourself better on.
One of the themes we've heard a lot of in this podcast is efficiency, that we're not just trying to create something. Okay, maybe we've created something, but now it's a matter of improving its efficiency and making it 4% more efficient, and then maybe next year another 3%, and maybe the year after another 1.6%. Would you agree with that?
100%. You just got to look at any technology in history. You're always trying to make it more efficient, whether if you look at internal combustion engines, from the carburetor through to fuel injection, through to hybrid, through to hopefully fully electric vehicles eventually.
Yeah.
That's just the natural progression as you get more and more efficient.
And my working hypothesis is that engineering isn't just a job, it's a way of life. And in fact, some of you engineers try and make your whole life as efficient as possible. You and Simon Thompson, I understand, used to see how optimised you could get your trip to the airport going to and from work, yeah?
Definitely. So while we were building the plant, we were based down in Bacchus Marsh, but we'd come back for the weekends. So Simon and I were in a endurance go-kart racing team together.
Right.
Which meant we would finish up late at night because, we're during construction, you're trying to get everything done. So we'd get a little bit of sleep before jumping on the plane to come to Sydney. And, we knew we had about 40 to 41 minutes to get to the airport park and get in. A couple of times we may have been on the other side. They say you got 30 minutes to check in. The Qantas systems at that point gave you to 27 minutes. So we knew.
And of course you worked that out.
We worked that out through, I'd love to say through good means, but unfortunately we missed a few flights as a result of that.
Well, trial and error.
Yeah.
Failures and
Exactly.
improving your systems. And in terms of testing and new calciners, you used to put food in them, is that right?
Precisely. So there's always been this concept that, we could make this perfect calciner that you'd put in mince at the top and get this perfect, grilled at the bottom.
Right.
Unfortunately, we didn't want to leave meat through the reactor, so we picked out the best alternative, which is popcorn. So we do the popcorn test. So we drop popcorn and
how far did you drop the popcorn?
So in our Bacchus Marsh reactor, it's about 42 metres above.
Right. So you tip popcorn in?
Well, unfortunately, we weren't quite hot enough at that stage, so
Right.
They just came out as hot kernels down below. But we're working towards getting the popcorn to actually pop.
Right. But birds also were a problem in that calciner? They used to come in, did they?
They came in and ate everything. So, within a plant, you have communications going between all the different sensors, and birds, unfortunately, love to eat cables. That results in, component A not talking to component B, and you're sitting in the control room, getting frustrated why it's not all working because, it was working yesterday and, the birds had ripped up all the cables. So,
What do you do about that?
You ignore it for a while, you try and work around it, but then eventually you've got to go replace it all and then engineer a solution.
Yeah.
So we tried all the, fake eagles, etc. But unfortunately, none of that worked, and we had to put up mechanical protection over all the cabling.
We used to have birds, they seem to have stopped now, but would just walk into our house and do a poo and then walk out again and kind of look us in the eye and say, huh. So we bought a couple of fake owls and we saw all the birds in our backyard, 4 of them just gathered in a circle looking at the fake owls. I'm sure they were saying, I reckon they're fake, they don't ever move. And then after a while, one of them kind of walked up to the fake owl and just walked around and walked into our house, did a poo. So
they're very persistent.
It's like that, isn't it?
Yes, exactly.
So when you finished the flash calciner, what did you do next?
We completed the flash calciner. At that point, Calix was learning what the technology was capable of, and we started moving towards this product called magnesium hydroxide.
Yep.
We could produce magnesium oxide outside of our calciner from magnesium carbonate, and we were trying to make this stable slurry, which we could sell into the wastewater market,
Yes.
or pH stabilization. So finishing that up, I was then involved with some Adam Vincent, who's part of Calix and runs the lime business now. But at that stage, I was working with him to develop the magnesium hydroxide slurry, which was a lot of trial and error.
Yeah, and tell us about the learning process. Like, you came in fresh out of uni and you're doing all these things. Now you're moving on to a very different project. Some organisations, they teach you by standing behind your shoulder and not giving you much responsibility. Some organisations, they throw you in and say good luck. How did it work for you in Calix?
So Calix was a relatively small team when we started. We had a big vision but a small team. Luckily, the upper management had a lot of trust in us, so they threw us in with a lot of responsibility.
Yeah.
It was a sink or swim situation. Luckily, we all swum and we got out of it. A lot of this was outside of probably what university traditionally teaches you. It's very structured and you follow this. Whereas in the real world, there is a lot more variables. There's managing people, managing costs, managing time, managing expectations, and that's not really conveyed in a university educational sense nowadays. Yeah. So that was a big learning experience. And while Calix did support that when we needed it, they also entrusted us to develop our own experience through it.
Right, and that's probably not for everyone. But
no, not everyone. But it's a great.
So you had to be kind of flexible, adaptable, kind of learn on the run. I guess.
Yeah, learn on the run. Learn outside of obviously magnesium hydroxide development's a much more chemistry based. So you're also learning outside of your traditional educational stream. So they supported that and it gave us the ability to learn how to gather information and assess situations that are outside of our wheelhouse.
Yeah. Now, in that period, am I right in thinking you were talking about how you didn't really like what birds were doing to the calciner before, but didn't you swerve off the road to avoid a bird with a 650-litre tank of diesel in the back of a ute?
Unfortunately, yeah, that did. And
you must really like birds.
At the time, yep, I was watching out for the bird. Post the event, wasn't as happy with the bird. But yeah, unfortunately, it slid off the back of the ute. The tie-down straps failed. And it happened to be when all the media was in town that week.
Oh.
But luckily, some guys locally came and helped me get it back on the ute, and I limped back with my pride a little damaged to present a damaged ute back to the Bacchus Marsh site.
So we've been talking about some of the engineering challenges that you faced, but then as you get more senior and experienced, you become more aware of time pressures, deadlines, and money pressures, budgets. So when you throw those two variables in the equation, how much does that complicate your job? Is it interesting? Are they difficult things? How do you go about meeting those challenges?
No, it's very interesting. When you're a young engineer, you're sort of oblivious to some of it. You know there's a deadline, you know there's a budget, but someone else is managing it.
Yeah, so it's their problem.
It's their problem. It's outside of, say, the core engineering you want to do with number processing. So when you throw those in the mix, suddenly you've got multiple hats on, which you're trying to manage, both delivering the engineering to an engineered, optimized solution, but also delivering to the budget and then delivering to the timeline. So you learn to manage those three main sort of drivers to ensure that you're delivering the best optimal solution you can.
Yeah.
So it's quite an interesting path to learn to which one becomes most important depending on the deliverable.
So you could have a great product that's going to take ages and be too expensive. You could have a second option that's going to be quick but even more expensive, and a third option that'll be a little bit slower but it'll bring you in under budget, and you've got to kind of toss around all those things. Precisely.
Yeah. There's the traditional triangle which has like quality, cost and time. And you can pick two, not three.
Right.
It's always the case, no matter how.
Do they teach you about the traditional triangle at uni?
No, I don't remember coming across it because it's always optimal when you're doing engineering at uni.
That's right. You never have to worry about deadlines or money. It's about making it perfect. So was it pretty stressful for you learning all this stuff?
Stressful, definitely, but it's exciting because it's something new. You're getting to peer behind the front facade. You can just see how it all works. So as an engineer, you love that part. You want to see how that goes. And it's another another part of the equation about delivering a solution. So it's exciting.
Let's bring in a fourth variable, people. So as you become more senior, you start managing people. How'd you find that?
Yeah, it's interesting. Engineers aren't known to be great at social situations. So, there's a bit of that's true in everyone, but not the mold doesn't fit everyone as well. So, no, I've learnt a lot. I must admit, I was always a very passionate person, and some of that passion can be perceived incorrectly by other people that don't get to know me. So, I've learnt to adapt to each person. Each person's different, so you got to learn how you're communicating with them, how you're engaging with them.
Sounds like you might have been being a bit more gentle. Is that what you mean?
Yeah, you could say so. Yeah, definitely.
I'm just reading between the lines.
Yeah, a bit more gentle, a bit not so black and white. So you know, there's a full spectrum out there. You got to focus on and make sure that you're not forcing one person into the other. The other part is you're helping someone build their career, so you want to make them the best person, not just deliver what you need. You need to make them grow into this perfect.
That's very well said, actually, because when you start managing people, you probably think they have to perform these tasks for me. I'm delegating them this task. I need this task done. You think about the task.
Yep.
But what you've just said is there's a transition from that, I think, to thinking about it from their point of view and how you can actually build their capacity and skills.
Definitely. And those first few years, particularly we're bringing on a lot of young engineers, is very fundamental to getting them ahead of the game and getting them ready to perform at the best they can.
And we should put you on notice in a few minutes. We're going to talk to one of those young engineers and see if all the things you're saying about how great you are at this are correct or not. Do you enjoy that aspect of it, training? And
Definitely. I think it's very rewarding to be able to pass on mistakes you've made and help people not have to go through all that.
Yes.
And that they can learn from it. But also you've got to let them make their own mistakes and then show them how they can learn from that and use that moving forward.
Calix has also set itself very strongly as having environmental values. That is, we're not just here to make a profit, we're here to help make the world sustainable. As someone who every year becomes more of a leader in Calix, do you have to kind of learn to model those values, to walk the walk?
Definitely. Calix itself has a sustainability program, which is covering the UN's sort of targets for 2030 and beyond. So we are closely encouraging those values into everything we do, from the project management and engineering. But it's also educating the young engineers and other team members to understand that these are important facts to deliver on what we're saying we do, and that it can't be just up the front end, it has to be in the back end as well. We have to see that sustainability that engrossed in everything we do.
Yeah. Well, that's what being an engineer at Calix is like from Matt's perspective. Let's get another point of view. Claire de Jacobi de Vallon graduated with a Bachelor of Chemical Engineering from RMIT Uni. She joined Calix in January 2021 as a process engineer, working on trials and developing test plans and much more, and joins us now. Hi, Claire.
Hi.
Why did you join Calix?
Well, I was graduating at the end of last year, going through the graduation process and applying for graduate positions. So I was doing that typical search for different positions to apply for, and I saw the ad pop up for the position at Calix, and it stood out to me. I think the work just seemed interesting and different, and I think even at uni, we started to have more of an emphasis on environmental and sustainable considerations, and how these issues have arisen from previous industrial processes and practices that we've been using. So when I saw the ad, it seemed like an opportunity for me to be part of the solution rather than contributing to the issues that we're seeing.
And you've heard what Matt said about being an engineer at Calix, and we should clarify, are you technically Claire's boss?
Yes, yeah.
All right. So we want you to speak freely, and I'll get Matt to say something that nothing can be held against you. How have you, you heard Matt talk about how different working was from what they teach you at uni. How have you found that?
Yeah, definitely. I think I was quite pleased to see that my knowledge and foundations were applicable. But yeah, what you learn at uni is just probably not even 1% of what you learn outside of uni. So yeah, it's been a huge learning curve for me to stop thinking theoretically and actually taking that knowledge and applying it to real life practices and uses.
And I asked Matt to, go back 10 years and describe a typical hour, if you like, of his job. Give us a typical hour of your job.
Oh, it varies a lot. I could be operating a plant. I could be assisting with process design work and data processing, looking at results, developing trials and test plans of things that we want to test in our plant. It varies from day to day.
Yeah. What's Matt like to work for? Speak freely.
Take
your headphones off, Matt. No.
I think he used the word passionate before, and I'll definitely agree with that. I think Matt has very high expectations and standards for all of us. And that's a good thing, especially for someone like myself that's recently graduated, and I'm learning all sorts of new processes and doing things for the first time. And it means that I know that the things that I'm learning and the work that I'm doing is done properly and accurately and thoroughly. So I think that's really important. And he also, again, I think he's already said this, but he gives me the space to make those mistakes and learn from them. And I think that's really important to my overall understanding and professional development.
And you mentioned before that creating a more sustainable world was one factor in your decision in deciding to apply for a job with Calix. Sometimes, you could be in a company that's doing something and your job's so specific and small, you don't really feel connected to the bigger purpose, if you know what I mean. I'm just wondering how connected you do feel to that purpose, if you're kind of aware of that all the time, or it's something you just think, oh, right, and we're doing something kind of cool as well.
I think, everyone that I work with, regardless of whether they're on the engineering team or not, has, sustainability and environmental considerations at the forefront of their minds. So it just seems to be integrated into everything we do. I don't think it's necessarily one example. I think it's just making it part of everything you do. Yeah.
And Matt talked earlier about, the role of an engineer really being to try and fail and work out why you failed and try again and keep going until you work out how to solve the problem. Have you experienced much of that, and how do you find it?
Yeah, definitely. I think again, it was already mentioned that, at uni you get a perfect problem that has a perfect solution, which is definitely not the case in real life. There's been a really exciting thing to be part of where you can try new things, and then whether they don't work or they work but they need to be improved, and you try again until you get something that functions, that works, and it's a very exciting moment, but it can be a very frustrating process as well.
Yeah. And have you been exposed to the world of budget and deadlines yet, and how are you finding that?
Probably not budget. Deadlines, but I've got my own personal deadlines, which I've always been one person who likes to stick to their deadlines. But definitely I don't have the accountability attached to those larger deadlines with projects.
Yeah. And would you want to, the fourth variable we talked about is managing people. Is that something you'd like to do down the track? Or do you want to stay away from them?
I think it would be something I'd like to do. I think it's probably the area I would need to improve the most in. It's something that I've not had experience with at all. And I think, people who go into engineering don't necessarily set out to be managing people. So it would definitely be something that I think I should work on and that I probably would like to do with more experience.
But that's true of many people in all sorts of industries, actually. They're a watchmaker or a pharmacist, and suddenly they're running a pharmaceutical store or running a watchmaking team. Did you get specifically trained in management, Matt, or did you just kind of pick it up?
I was lucky enough just to pick it up, and clearly it hasn't gone too badly based on Claire's praise. But
well,
yeah.
she is. You are in the same room.
So no,
virtual room.
Yeah. No, there was no direct training, but there has been a lot of support when I've made mistakes. So again, the culture within Calix of supporting people when they can go out on their own limb and make their own mistakes and learn from it.
Yeah. What advice would you have, Claire, for someone in their final year of engineering about your experience and about things to look out for, I guess, in deciding what they want to do?
I've had such a great experience, and I know that's not everyone's experience, but I've come into a workplace that's very supportive, that allows me to be independent and make my own decision. So I don't know if I have the best advice for that.
What about something you wish you'd known in January 2021? Something you think, right, in April I worked out I needed to do this, not that.
I think it's probably just the willingness to make mistakes.
Yeah.
Coming from a sort of more culture of tests and exams and assignments and wanting to get, 100% on them. It's not about getting everything perfectly right the first time. It's about trying something, reviewing it, and working out how to do it better. And
you don't really, in my experience, you don't learn much from success. You just tell yourself how great you are. You learn from failure.
Yes, definitely.
Any thoughts on that?
Oh, definitely. You don't want to succeed. You want to fail and build it up. It's been my life experience so far anyway.
And what about you? Advice for a final year engineer or new engineer? Some mistakes you made that you might be able to help them avoid?
I think early in your career, you tend to be a bit standoffish. You don't want to push yourself into the conversation. You assume these people that are above you know all the answers. They have all the solutions. But what you should really be doing is getting in and questioning everything they do, not in a disrespectful way, but as in an inquisitive way, because they're going to bring you in, they're going to get you more involved, and you're going to learn a lot more from that. I think we need to encourage more and more of that to occur.
Claire, what do you think about that? It can be quite difficult when you're new at an organisation, even if they say ask any questions, to have the confidence to do that. How did you find that?
Yeah, definitely. Something I am still definitely working on. But yeah, it's the willingness to ask questions and not to realise that not everyone expects you to know everything straight away. And then I think another probably step further than that is to put your opinion forward, to question things and ideas that other people put forward, and to review it and
have you done much of that yet?
My opinion will sometimes be put forward.
Yeah, good.
But yeah, definitely working on it still, and it can be quite daunting going into a meeting or a room with all these really talented, passionate people, and having the confidence to express your thoughts.
Do you have that thing where you're in that meeting and you want to say something and you're like running it over in your head like 5 times exactly how you'll say it before you have the guts to say it?
Yeah. The microphone gets turned on and off a few times to try and pick the perfect moment.
Do you still have that, or you just say whatever you think?
I've always just said whatever I think.
Yeah. But you would have been like that when you started, probably.
Yeah. I've always been a bit, let's say, arrogant. So I got forward and had my say. And unfortunately, when starting with Calix, we were involved with a lot of consulting companies for the first project, and there wasn't a lot between myself and Simon and management. So we had to deliver, which meant we had to get in front of these senior consultant engineers and tell them what we wanted and tell them what we thought was wrong. And we found mistakes in a lot of their work, unfortunately, at that time.
Really?
Yeah. So I think that that has developed a lot within Calix to support this sort of get up, tell your opinion. You're looking at it from a different perspective to even what I'm looking at it, and doesn't mean that that's incorrect. We all, as we get older, become, horses with the blinders on. We look down one path, and it's nice to get the young, fresh views on a project.
And that's interesting because it ties in really in an interesting way with what you were saying, which is so true about how at uni or at school you're wrong or you're right. Not saying that schools and unis don't support people to say go away and look at what went wrong and da-da-da, but, you are particularly in, maths, science, engineering type questions. 4 + 4 is 8, you're right. If it's not 8, it's wrong. So it is an adjustment, isn't it, to that way of thinking?
Yeah, for sure. I think, being young, you kind of see the world black and white, and it's a whole lot of grey.
Yeah. Oh, look, it's very interesting talking to you both about what it's like being an engineer in Calix. I was kind of hoping Claire would come in and just blow everything Matt said out of the water, but you've kind of been pretty much consistent. So, look, thank you very much, Claire, for joining us. Lovely to speak to you.
Thank you for having me.
And thank you very much, Matt.
Thank you, James.
Thanks for joining us on Innovating for the Earth. Talk to you next time.